All right, looks like we're recording. I want to walk through the 2005 Calculator Active area question that I have shown here, and you should have it in your notes. We'll walk through how to do it. We can do parts A and part B. Part C we won't learn until we get into section 6.2 of our textbook, so we'll hold off on part C. But A and B, kind of a nice reinforcement of what we started today on day one of area between the curves. So if I look at this, it says let f and g be the functions given by f of x and g of x. Let R be the shaded region in the first quadrant enclosed by the y-axis and the graphs of f and g. So we needed the y-axis just to close up this left side. Otherwise, I can see that this function's getting, you know, blocked or intersected here and here. So we've got a closed figure for S. R would have been closed. It would not have been closed without talking about the y-axis as well. So that would be the purpose of the y-axis fitting in there. Let S be the shaded region in the first quadrant enclosed by F and G. All right, so I'm just going to clear my ink there. Now, the first question says find the area of R. And R, then, I can see this would be g of x, because here's my g of x. Remember how we used some color to talk about and be able to follow our functions a little bit better. So I can see that g of x is over f of x. So when I calculate area for part A, and then we want to find area of region R, I would do top minus bottom, and I want to integrate then my top function minus my bottom function. And since the blue is always on top of the red function there, we can do this with respect to x. Our representative rectangle would be a vertical rectangle, noting it has width then along the x-axis, so it's got a dx width, and that just kind of helps inform me that all of this stuff should be in terms of x. So I'm going to have the integral, top function is g, bottom function is f. Well, I need bounds then, x equals something and x equals something for my two boundaries. And I can tell that the left side is when x equals 0. So now I know that this will be a 0 here. But what about this right-hand bound right here? How am I going to find that spot? Well, that, of course, is going to be where these two functions intersect. Now, let's just take a quick look at these functions because they look a little interesting. We have f of x and g of x. That looks a little tough for me to solve. Thus the reason it's sitting on Calculator Active. We need to go into our calculators and set these two functions equal to each other and find out where that intersection is. So, if you need to, pause the video, get your calculator. I have preloaded my two functions. So I've got 1/4 sine pi x, and then I've got 4 to the negative x. If I just double check my mode, I am in radians, so cool. It should be good stuff. With the sine function being in there, I might do a zoom 7, I believe is the trig one. And look at, we get quite a large region here, right? Can you pick up that this is kind of the region that we're zoomed in on in quadrant 1 there? So what I want to do is I'm going to trace 0, get into that a little bit there, and now I'm going to zoom in on that region that I just highlighted. This is looking so much better, isn't it? I can see here's that left part that we're interested in, and then we've got this other right region that's in our picture. So I'm happy with my graph. I can find that intersection point. To do that, we are simply going to do what? Second, calculate, and I want to find where they intersect. I'm after this first intersection point, so I'm going to get located nearby. There's the second curve. You can do a guess if you like. There's my intersection. So I'm going to try to sweep this off. Hey, it came first try this time. And there is my intersection. So my integral here, oh good, swing this down. My integral is going to go to 0.1 178,218. I need quite a few decimal places if I'm going to be an accurate answer out to 3 decimals when I'm done. I'm also going to take and store that value in my calculator. So to do that, I need to go to my home screen. I'm going to go second quit. I want to take that x value, not the xx value, and I want to store it into, I'm going to call it alpha A. All right, there's that number, right? Stored in alpha A. Now we can proceed with finding the area of R. I need to integrate, and for me, I've got to remember my g of x, which is the 4 to the negative x. I believe that's my y2. Yeah, that's my y2 one. So this, for me, is going to be y2 minus y1. Second quit. I like to not keep rekeying these same functions over and over. So this, to me, is my y1. You know what, I bet I could get rid of this, couldn't I? Let's delete that for a moment. So this is my y1 equation, and to me, this was my y2 equation. I might just jot that down so I can keep it straight. We need to integrate between 0 and my alpha A, which is the 0.178. I want my g function over the f function. So g was y2 to me, and that would be there. And then I need to subtract the y1 equation. Please don't just watch me do this. I want you keying that so that you are very comfortable with your calculator. 0, 6, 4, or the other answer the AP would take would be 0.6465. So you can round or you can truncate. I think you remember that part. Alrighty. Now that is the area for region R. This problem was worth 3 points. 1 for the limits, 1 for the integrand part, and then of course 1 for your answer. So that was 3 points, pretty easy. Let's go after region S. Region S, I have the f of x functions on top, and then it is over top of the g of x function, isn't it? So my integral, see if you can write it. Hit pause, write it out, test yourself. Area of S is equal to the integral of f of x minus g of x. For the AP exam, I do not have to write this stuff out. If they've already referenced it and assigned it to different function names, I can use that in my body of work and be just fine. If you like to write it out, there's no harm in that either. Now, I need to integrate from this point out to this point. Well, I already had established that last intersection point. Let's see if I can remember it. 0, 1, 7, 8, 2, 1, 8, and it's stored in my alpha A. And now I need that other intersection point out here. How am I going to get that? I'm going to go back to my calculator and graph that thing. Now what we want to do is capture this intersection point a little further to the right. So second calculate, I want the intersection of it. Move yourself closer. Okay, and then now I'm on my second curve, my red curve. I'm asked to guess. Well, I'm pretty darn close anyway. I'll hit enter. And I pick up, ooh, look at how nice that is. It's 1. Okay, cool. It intersects at 1. And next thing we want to do is actually do the integration. So back to the calculator. I'm going to quit off that page, and my second equation is the g of x, right? Yeah, so for me, I'm going to be keying y1 minus y2. Not that the AP cares at all what y1 and y2 are, unless I assign them. I could say y1 is f of x, couldn't I? And I could say y2 is g of x. Now I suppose I could actually hand them this information because I have defined what they are. All right, now let's get into the integral. And I want to integrate between, alpha A, the 0.178 number, and then up to 1. I now need y1, alpha f, or alpha trace. I need y1 minus alpha 2, pick up that 2 there, and dx. And I get an answer of 0.410. Cool. That's all to it. Let's do it. That was 3 points as well. If you can guess, it was very much the same as the last one, where the intervals were a point, the integrand was a point, and the answer was a point. I hope you can kind of start getting an internal feel for assigning points as well. What I'd like you to work on for homework is the problems here on the day 2 homework. You will watch for some places. This one says don't use your calculator, which means I should be able to find these intersection points by setting my functions equal to each other and doing the algebra necessary. This one does say use your calculator, so to find this intersection points, there's one too. You'll probably want to use your calculator on it. This is for problem 5, but same is true for these others. You're probably going to use your calculator to come up with that. No calculator for this region R, but look at they give you the intersection points, so that should be pretty easy. Finding area R. They want us to work in 2 different modes here, working with x's and working with y's. So if I'm working with x's on this number 7, here's the first curve, here's my other curve. And I need to, because top minus bottom, blue, I could think of this being y equals 0 as a curve. I really need to bust this into two regions. I would have region number 1, let's use this narrower one. I could do this region by doing y, the blue curve, integrated from, so I'd integrate 0 to whatever. Oh, I know it. It's 4, 0 to 4. Not writing real well. Of this curve, and I can tell that that is a square root curve, can't you? Hopefully you know your functions, so square root 0 to 4 would get me this area, should we call it area 1? And then area 2 over here switches to our linear function, and that's going to pick up 4, 2, and then you'll want to figure out what that point is. And you would be able to set 0 equal to 6 minus x, yeah, and figure out when does it equal 0? Well, it appears to be 6, doesn't it? And so then I can integrate on that. That would be working in x's. If I wanted to work in y's, I may not have to use 2 integrals to do y, right? Because now if I think about right minus left, there's the red function, here's the blue function. Red is always to the right of blue, and I could set that representative rectangle in horizontally now. And so I think when I'm working in y, I can work in only one, with one integral. Right minus left, red, for me it's red function, which is the linear function, 6 minus x. Take away the blue function, square root x. Ooh, dang it, I can't do that. I can't have it in terms of x if I'm going horizontally, can I? We need to solve these out, so solve for x. That means I'm going to square both sides so I can get x. So x equals y squared. X equals y squared. And then solve for the red one. let's see, we would add x, subtract y. So x equals 6 minus y. And that is this function with y as its independent variable now. Perfect. So I'm going to have right minus left, the blue curve, dy. And don't forget, you've got to have y equals and a y equals number. Where do I begin and what height do I finish it at? So that's going to create your bounds. So I kind of helped you out on B a lot, but that's okay. Number 8, let R be the region. Find the area. Ooh, that's going to be tricky. I think I would work in X's and I would split. So I'd be curious what that intersection point is. They don't give it to you, but calculator active, so find it. I think you're going to have a region 1 and a region 2. Okay, so do it in 2 steps for number 8. Otherwise, the answers might be on the back side of that homework. I can't remember if I copied them there or not, but give it your best, you guys. These are very much like the AP questions, so definitely worth spending some time on. Have a great day. Bye-bye.